In today's video, you will learn how to write the equation of a circle in standard form from a graph. You will also learn how to identify the center, determine the radius, and graph the circle given its equation in standard form. If your lesson is on circles and you are on determining the equation of a circle in standard form, or if you have an assignment on this topic, or if you are preparing for a test in math or a test in geometry in particular, or you're someone who is interested in learning math, then this video is for you. Let us first describe what a circle is. A circle is a closed two-dimensional figure in which the set of all points in the plane is equidistant from a given point called the center. The distance between the center and any point on the circle is called the radius of the circle. Since we're going to write the equation of the circle from a graph, let us put our circle on a Cartesian coordinate. For a circle, its equation in standard form is x minus h squared plus y minus k squared equals r squared, where hk are the x and y coordinates of the center of the circle, and r is the radius of the circle. This equation will serve as our formula in writing the equation of a circle in standard form. Hence, we will call this our equation formula. The equation formula tells us that we need the center of the circle hk and its radius r for us to be able to write the equation of a circle in standard form. Okay, let us work on this example so you will learn how to write the equation of a circle in standard form. Here is the problem. Write the equation of the circle in standard form given its graph. Remember that we must know the center hk and the radius r of the circle to be able to write the equation in standard form. Let us examine the circle and locate its center. Here is the center hk, but where is it in the Cartesian coordinate? What are its coordinates? To find the coordinates, we start with h being the x coordinate of the center. Here is our x coordinate. What is the value along the x-axis? Right, it is 2. This is the x coordinate of the center of our circle. Next, we find k, the y coordinate. Here is our y coordinate. What is the value along the y-axis? You are correct. It is 3. This is the y coordinate of the center of our circle. So the center hk is at 2, 3. What are the signs of the numbers 2 and 3 here, by the way, learners? You are correct. They are both positive. Remember these, learners. If you do not see any sign before a number or a variable, that variable or number is positive or has a positive or plus sign. Here, h and k are both positive. Likewise, 2 and 3 are both positive. We just do not write the positive or plus signs. Let us now find the radius. How do we do that here? We draw a horizontal line from the center to the circle and determine its distance by counting the number of units it covers. Let's go and count. 1, 2, 3. The radius is therefore 3 units. You can also draw a vertical line from the center to the circle. Let us do this and again count. 1, 2, 3. What do you notice, learners? You are correct. the radius is the same. Therefore, all radii of a circle are the same in length. For this circle, the center HK is at 2, 3, and the radius R is 3 units. Let us have our formula equation again for the standard equation of the circle. Next, we substitute the values of H, K, and R into our equation formula. We're almost there. We only need to multiply 3 by itself. Remember, the 3 squared means 3 times 3. 3 times 3 is 9. Bingo! We now have the equation of the circle in standard form. How was it, learners? Easy, right? Let us have this second example. The problem is, write the standard form of the equation of the circle shown on the graph. Do you remember the steps we did earlier? What were those again? You are right. We located the center HK of the circle and we determined the radius R. Let us do it. So the center HK is -3, -1. How do we determine the radius again? Right. Draw a horizontal or vertical line from the center to the circle. Then determine its distance or length by counting the number of units covered by that line segment you have drawn. So here we go. 1, 2. The radius is 2 units. Now we have what we need. The center of the circle HK at -3, -1, and its radius R, which is 2 units. Take note, H here is -3 and K is -1. Let us have our formula equation again. We substitute the values of H, K, and R into our formula equation, and we have this. Recall that negative and negative becomes positive, so our equation is rewritten as multiplying 2 by itself on the left side of the equation gives us the equation of the circle in standard form. Any questions so far? Write your question below and I will try to respond to it. Okay, let us work on example 3. The problem is, write the standard form of the equation of the circle shown on the graph. As usual, we need to locate the center HK. Where is the center of the circle? You are correct. The center is located at 0, 0, the origin. What is its radius R? Remember how we did it? Okay, we draw a horizontal or vertical line and count the number of units from the center to the circle. Ready? Go. 1, 2, 3, 4. The radius is 4 units. We can now substitute the values of H, K, and R into our equation formula. Look at the equation. We have these expressions, x minus 0 and y minus 0. Remember that a number minus 0 is the number itself. Like 2 minus 0 is 2. What is 10 minus 0? You are right, it is 10. So what is x minus 0? You are right, x minus 0 is x. What about y minus 0? You are right again. Y minus 0 is y. So the right side of the equation can now be written in this way. On the left side of the equation, we multiply 4 by itself. We now have this. Because there is only the variable x inside the parentheses, we can remove the parentheses. The same with the y. We can remove the parentheses there as well. The equation of the circle in standard form is therefore easy, right? This time, let us do the reverse. Let us find the center of the circle, its radius, and then we will graph the circle given the equation of the circle in standard form. Here is the problem. What are the coordinates of the center and the length of the radius of a circle with the equation x minus 3 squared plus y plus 1 squared equals 9? Now listen to this. If we can rewrite the given equation into a form like the equation formula for the standard form of the equation of a circle, then we will be able to identify the center and the radius of the circle easily. Look at the formula equation carefully. The variables x and y are each followed by a minus sign, and the r on the other side of the equation is squared. Our target here is to write the given equation in this form, where the variables x and y are both followed by a minus sign, and the radius r is squared. Let us examine the given equation and rewrite when needed. Let us look at the first term of the given equation. It is x minus 3 squared. Is the form like that of the first term of the formula equation? Is x followed by a minus sign here? Yes, it is. So we don't touch it, we leave it as is. Let us look at the second term of the given equation. Here, y is followed by a plus sign. Take note that in the equation formula, y is followed by a minus sign. We must therefore rewrite this. How can we rewrite y plus 1 such that a minus sign will come after y and not a plus sign? Can we do that? Yes, of course. We write it as y minus negative 1. Remember that negative and negative is positive. So y minus negative 1 is just another way of writing y plus 1. Let us do it here on our equation. Here it is. Now we can clearly see the values representing h and k. So here, h is 3 and k is negative 1. What about the radius? Remember that the number on the left side of the equation is r squared. To get the value of r, or the radius, we think of a number which, when squared, will give 9. What number, when multiplied by itself, equals 9? Yes, that number is 3. That is, 3 squared is equal to 9. Another way of finding the number is by getting the square root of 9. That is, square root of 9 is 3. You can use a calculator in getting the square root of a number. The use of a calculator is helpful when the number is not a perfect square. So, 9 on the left side of the equation is now written as 3 squared. Let us apply that on our equation. Here is our equation now. Here, we can easily identify the center HK and the radius R. Therefore, the circle with the given equation has a center at 3, negative 1, and a radius of 3 units. With the center 3, negative 1, and the radius r equals 3 units, we have everything we need to graph the circle. To graph, we start by plotting the center. Next, we work on the radius. Remember that the radius is 3 units. Starting from the center, count 3 units to the right, then mark where you stop. Again, starting from the center, count 3 units to the left and mark where you stopped again. From the center again, move 3 units up and likewise mark where you stop. Again, from the center, move 3 units down and mark where you stop. Next, all you need to do is draw the circle using the marked points as your guide. There you are, learners. We have answered the problem. That was quite easy, right? Let us summarize what we have learned on this video. First, we have learned that a circle is a closed two-dimensional figure in which the set of all points in the plane is equidistant from a given point called center. The distance between the center and any point on the circle is called the radius of the circle. Second, the equation of a circle in standard form is x minus h squared plus y minus k squared equals r squared, where hk are the x and the y coordinate of the center of the circle, and r is the radius of the circle. Third, the steps in writing the equation of a circle in standard form from a graph are: locate the center hk of the circle from the graph. Next, determine the radius r of the circle. Finally, substitute the values of the variables h, k, and r found in steps A and B into the equation formula of the circle in standard form. Fourth, to determine the center and radius of a circle given an equation of the circle, you must rewrite the given equation into a form like the equation formula of a circle in standard form, then identify the center hk and the radius r. Finally, to graph a circle, you need the coordinates of the center and the value of the radius of the circle. Once you have these two, start by marking off the center point. Then from the center, move to the right by counting the number of units that represents the radius. Then mark the point where you stop. You can do this process several times to mark several points. Then draw the circle using the marked points as guide. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and do not forget to like,